In this video, we are going to derive section formula. Previously, we have talked about the distance formula, which was based on the 2 points in a Cartesian plane. Once again, we will draw a graphical zone, a Cartesian plane. In the same way, and we will take 2 points in this Cartesian plane. Let it be A and another point here B, and the coordinates of A and B are x1, y1 and x2, y2. Okay, and we will join them. So the distance AB we found out by using distance formula. This is all we have done. Now, since we are talking about section formula, the word section means the part of the line joining 2 points A and B. So let us take a point here, let it be P. So P is the point which is dividing AB into 2 parts, 2 sections. Let the coordinates of point P be x, comma, y. And the section, the ratio in which it is dividing AB into 2 parts, let this ratio be M1, M2. Okay. Now let's draw perpendicular on x-axis from all 3 points A, P and B. Let this be M, let this be N, and a perpendicular from B also. Let this be Q. Okay. Also, from point A and from point P, draw 2 lines parallel to x-axis. So you will get 2 triangles. Let this point be R and S. So this is the complete figure for deriving section formula. Okay. Now, if you look at the triangle APR and PBS, we have AR and PS parallel to x-axis. That's why AR and PS are parallel. And PN and BQ are drawn perpendicular to x-axis. Therefore, PR and PS are also perpendicular. So, if you compare 2 triangles, in triangle APR and triangle PBS, you will find that angle A is equal to angle P. These 2 angles are equal as they both are pair of corresponding angles. Okay. And angle R equal to angle S. Each 90 degree. That means we can say that triangle APR is similar to triangle PBS by angle criteria. So if the two triangles are similar, then their corresponding sides are proportional. Therefore, AP upon PB, this upon this, is equal to AR upon PS is equal to PR upon BS. Corresponding parts of similar triangles. Now let's take the values of these parts. AP upon PB means M1 upon M2 is equal to AR upon PS. Now the distance AR, the value of AR you can find out from x-axis. Coordinates of A is x1 y1, coordinates of R for which value is x. So AR will be equal to, how to find that? Distance of R from origin, this distance is x. Distance of A from origin, this distance, x1. But distance AR means distance MN, which is x minus x1. That means from this much part, if we subtract this much part, we get this part. It will be x minus x1 upon distance PS, this distance, x2 minus x. Similarly, PR upon BS, this distance, PR, coordinates of P, x comma y. So distance on the y-axis, y, and distance of this R, y1, it will be y minus y1 upon BS, y2 minus y. Okay, now let us take one by one. First we will take these two and then we will take these two. So if we are taking these two, M1 upon M2 is equal to x minus x1 upon x2 minus x. So by cross multiply, M1 into x2 minus x is equal to M2 into x minus x1. Therefore, M1 x2 minus M1 x is equal to M2 x minus M2 x1. So now I am going to transpose this one here, so it becomes plus, and this one here, so it becomes plus. So M1 x2 plus M2 x1. M1 x2 plus M2 x1 is equal to M2x, and plus from here it goes M1x. That implies M1 x2 plus M2 x1 is equal to, we take common x and we get M2 plus M1. I am arranging it as M1 plus M2. This implies x is equal to M1 x2 plus M2 x1 upon M1 plus M2. This is your section formula for coordinate of x. Okay. Similarly, in same way we can find out the coordinates of y. So this time we will take M1 upon M2 is equal to y minus y1 upon y2 minus y. So once again, on cross multiplying, M1 into y2 minus y is equal to m2 into y minus y1. So it is m1 y2 minus m1 y is equal to m2 y minus m2 y1. And by transposing m1 y2 minus m2 plus m2 y1 is equal to m2 y plus m1 y. So m1 y2 plus m2 y1 is equal to y taken common and rearranging m1 plus m2. Therefore, y is equal to m1 y2 plus m2 y1 upon m1 plus m2. This is the section formula for y. So, if we are given a straight line in a Cartesian plane and a point which is dividing that straight line into two parts, in two sections, so for that point, the coordinate x and y can be derived by this formula, which is x is equal to m1 x2 plus m2 x1 upon m1 plus m2 upon, and y is equal to m1 y2 plus m2 y1 upon m1 plus m2.